Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem today, and today's problem is insert, delete, get random in overfun. So basically there will be three operations, that is insert a value, delete a value and get random value, and all of the operations should be performed in overfun. Right. So basically in the insert function, if the value is already present, we have to return false, otherwise we have to insert the value. In the remove function, if the value is already present, we have to remove the value, but if it is not present, we have to return false. And in getRandom function, we have to return a random value from the current value set of values. Right. Now, all of this should be performed in overfun, and one very straight away way of doing this is create an unordered map, assuming all the operations in the map are going to be O of 1, and they have explicitly mentioned that it should be the average complexity, not the worst case complexity. So the average complexity of unordered map is O of 1, right? So now the insert part is very simple, because if the value is found, then we return 0, otherwise we set the value and return 1. If the value is not found here, that means we just return 0, otherwise we erase the value from the map and then return 1. And then coming on to the get random part. So this is the part which I believe is a little bit different, because I'm not sure of the complexity of this particular part. I believe that it is O of 1, but again I'm not sure. So what it does is, the next function, it receives an iterator and we pass a value to it. So this value can be an integer value, so 0, 1, 2 and so on. Now the next iterator will basically do, let's say if the first iterator is pointing towards a of 0, then if I pass a value, let's say 3 to it, then it will give me a of 3, right? So this is roughly what it does. So what I'm trying to do is, I'm trying to create a random value with this rand function and then modding it with f dot size. So that means all the values that it generates will be starting from 0 until less than size minus 1, right? That means all the values will be inside this particular map only. So I add that particular value to the begin vector and I can access a random value from the map. So since the values are actually stored in the first part as the key, I return the first part of it. Now this particular part works. So let me just quickly submit this and show you that this is working. So you see this passes all the test cases, but again I am saying that I am not sure of the complexity of this one, so we will discuss an alternative approach, right? So let me explain you the approach. The next approach that I am going to discuss is, will definitely have a time complexity of O of 1, but the space complexity is O of n, right? That is why I wanted to discuss this particular approach second, because in the previous approach it works, but I am not sure what is the complexity of the next function. But for this particular approach, I am sure that the complexity will be O of 1, but the space complexity will be O of n, right? So let us see how we can solve this problem. Let's say I have a vector, right? So if I have this particular vector, we will have certain values inside it, right? So let's say this is 1, 2, 3, 4, 5 and 6 and 7. So now let's say you want to remove 4. So what you can do is, you can swap 4 with the last position. So we can swap these two elements. So 7 comes here and 4 comes here. Now popping the last element in a vector is O of 1 operation. So I can clearly pop back this particular element. So now this particular element has been removed, right? And accessing, so we know that we will be able to remove the element in O of 1. Now accessing is also O of 1. I can just take a random index and just access the value at present at particular index. Now accessing has been done. Now coming on to the insertion part, I just have to insert an element to the back of the vector. So all of these operations will be O of 1. The only thing that I need to do now is maintain the index of each of these values, and that anyways I was already doing here. I was not maintaining index, but I was just storing a dummy value 1 for that particular map value, right? So I was anyways using that particular space, so why not use that space to store an index, right? So all of the operations are pretty simple. Let me just write it first. So I'm just going to create a positions map and I'm just going to create a vector of values, right? Now what I'm going to do is a little bit different. So initially what happened was, if it is not present, so I'll have to change the names, right? So if it is not present, if it is already present, I just return 0. Otherwise what I do is, I just set position of this particular value as values.size, and then I'll just push back values dot push back this particular value. Right. Now what this will do is it will push the value to my vector and store its index in the positions map. Right. Now coming on to the remove function, it will check whether my element is present or not. If it is not present, I'm just going to return 0. Otherwise, I'll have to remove that particular element. But before removing the element, what I'll have to do is, let's say I store the index of the element. So it is in P1 now, and the last element will be at v dot size -1. Right. So these are the two positions that I have. So P1 is the position of the element that I want to remove in the vector, and P2 is the last position. Now what I can do is swap v of values of P1, values of P2. Right. Now this also has to be values. So what this will basically do is it will move the element that I want at the end of the vector. Now since I also changed the position of another element, then I'll have to update position of values of P1 should be equals to P1. Right. So now what happened was, there was an element, let's say here, there was an element present at the back. Right. So let me erase this. So initially 4 was here and 7 was here. Right. Now what I did was I took this particular position as P1, took this particular position as P2. Swap both of the elements. So after swapping, 7 comes here and 4 comes here. So I am anyways removing this particular element, so I don't care about its index. But I have moved a new element to position P1, so I have to update the index of 7 as P1. Right. That is what I am exactly doing. I update the position of whatever element is present at P1 now as P1. Right. And then I have to erase this particular value that was to be deleted, post.erase value. Right. So these are all the operations that I have to do. Now at the end, the accessing part will be O of 1, because what I'll do is values and rand mod values dot size. Right. So this will help me access a random element. So let me quickly try to run this particular part to see whether it is working correctly or not. So okay, so I have to change these variable names, right? So post.find and yeah. So let me quickly compile it. Yeah, so it is working fine now. Let me just try to submit it and see if there is a difference in the time taken by the approach. Okay, so we are getting a wrong answer. I'm not sure why. So we are just going to use this particular test case and see. We initialize, we insert -1, we remove -2. So I'm just removing the old test cases. So I only have one to focus. At the end, we're just accessing a random element. So my output is returning -1, but so it is getting accepted here. I'm not sure why is it like this. So I'm running the test case here, it is getting accepted, the same test case. Let me try to submit it again and let's see what happens. Okay. So I'm not sure why this strange behavior. I'm getting -1 output here at the end and I'm getting -2 output here at the end. Okay, so I got the mistake. I did not pop the value here. So I did everything but just did not pop this particular part. Now let me quickly compile this, and obviously this is random, so it was accessing a random value, so that is why it was working somewhere but not working at the other place. So let me just run this, submit this now, and let's see what happens. So you see it is passed, although not much of a difference, but from 200 milliseconds we have boiled it down to 169 milliseconds. So that was an improvement. That roughly says that that particular next function also works in O of 1. But this was just another interesting approach I had to share. So that is it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.